Hey guys, Josh from Stack Audio here. Today I'm bringing you a video on the science of speaker isolation. If you have any questions or comments, please leave them below. Every loudspeaker has a problem its designers can't fully solve on their own. When a drive unit moves forward to push air, Newton's third law means an equal and opposite force is pushed back into the cabinet. That energy has to go somewhere, and where it goes shapes what you actually hear. Speaker engineers spend enormous effort containing this energy inside the cabinet itself. Bracing, constrained layer damping, composite materials, mass, stiffness, all of it is designed to stop the cabinet resonating along with the music. You can feel this yourself. Rest your fingertips on a speaker cabinet during a bass-heavy passage. That movement is the energy that we're talking about. But no loudspeaker exists in isolation. It always sits on something: a stand, a carpet, a suspended floor, a concrete slab, and every one of those surfaces has its own resonant behavior. The moment vibrational energy crosses from the speaker into that surface, the surface becomes part of your playback system. It stores energy, then releases it back, delayed, smeared, out of time with the music. This is why two identical speakers can sound noticeably different in two different rooms. The floor has become part of the speaker. The most common solution people reach for is compliant isolation. Foam pads, rubber feet, spring-based isolators. For some applications, these work brilliantly. Sensitive electronics benefit from being decoupled from external vibration. Subwoofers benefit from reduced low-frequency transmission into the structure. That's why we use compliance in our own Alva EQ and Alva SW isolators. Different problem, right tool. But for full-range loudspeakers, compliance has two real limitations. The first is time domain energy storage. Most affordable compliant materials behave more like a spring than a true damper. They absorb energy under load, then release it back into the system a moment later. Think of it like landing on a trampoline versus landing on sand. The trampoline stores your energy and throws it back. The sand simply absorbs it. With compliant isolators, transient information isn't lost, it's redistributed in time. The leading edges of notes soften, detail blurs, the attack of a drum or the pluck of a string loses its precision. The second problem is more fundamental. Loudspeakers are designed, measured, and voiced on rigid, stable platforms. The crossover network inside the speaker is engineered around the precise physical position of each driver, tweeter, mid-range, and woofer. The time alignment between those drivers and the phase relationships that make them integrate coherently all assume that the cabinet is fixed. When the cabinet is free to rock, even subtly, the acoustic center of each driver moves with the music. No crossover can compensate for that. The engineering built into the speaker is being undermined by the thing meant to improve it. At the opposite extreme, spikes are often assumed to eliminate vibration entirely. They don't. They provide an efficient mechanical path into the floor. On carpet, spikes do solve one problem well. They pass through the soft layer to a firmer surface beneath, giving the speaker a stable footing instead of a wobbly one. But stability isn't isolation. The spike is still a direct mechanical connection, energy still travels into the floor, and the floor can still return it. On hard floors, the effect is starker. The energy transfers straight into a structure that's often reflective and resonant in its own right. The same speakers on a suspended timber floor will sound meaningfully different to the same speakers on a concrete slab. Not because the speakers have changed, but because the floor has become part of them. That is a serious limitation. Your speaker's performance shouldn't depend on an architectural variable that the manufacturer can't control. This is why we developed the Alva speaker isolator range. The Alvas hold the cabinet rigidly stable, the way that its design is intended, while absorbing vibration internally through our patent-pending particle impact damping technology. Rather than relying on controlled movement, Alva dissipates vibrational energy through thousands of micro-collisions between engineered particles inside a constrained structure, converted to heat by eternal friction. It isn't stored, it isn't returned, and almost none of it reaches the floor. The result is a stable mechanical reference for the loudspeaker, independent of whatever it's sitting on. No rocking, no delayed energy release, no floor dependency, just your speakers revealing exactly what the designers intended them to do. And if you wanted to test this claim yourself, we do have a comprehensive 60-day money-back guarantee which applies worldwide. If you feel the products don't add significant benefits to your system, we provide a prepaid returns label and we will process a full refund. Thank you very much for watching the video, and again, if you have any questions or comments, please leave them below. Thank you.